All right, let's take a look at some notes to help us with Chapter 8, the geometry section in ALEX. Again, this is the last homework assignment uh, for our ACM course this year. And it is in ALEX, unlike the logic section. So we don't get too in-depth with geometry, but we'll look at angles, triangles. We'll deal a bit with circles and the Pythagorean Theorem. So there are three kinds of angles. You have a right angle, which is exactly 90 degrees. Kind of sketch a right triangle here so that I can point to this little symbol. When you see that symbol in a triangle, that kind of a little box there coming out, maybe it's supposed to make a square. But that's our symbol to show us that we are looking at a 90-degree angle. It makes that T kind of intersection if I continue this line going out. So we'll look at right triangles in a bit. We have acute angles, which are less than 90 degrees. If you ever used a protractor, that's how you can kind of measure how many degrees an angle has. And then an obtuse angle, which is more than 90 degrees. Let's look at our types of triangles. We know that a triangle is three sides. A triangle has 180 degrees inside of it. So no matter how you draw your triangle, the angles, if you used a protractor and measured each one, would all add up to 180 degrees. And so first, we're going to look at classifying triangles by their angles. We have a right triangle, which I just kind of sketched there. In a right triangle, one angle is 90 degrees. And you'll be able to spot that angle with the little symbol. In a acute triangle is a triangle in which all angles are less than 90 degrees, or all angles are acute. So acute, parentheses, less than 90 degrees. And maybe how you basically kind of think about a triangle is usually acute. All of these angles would be less than 90 degrees. Finally, we have an obtuse triangle, which is a triangle in which one angle is obtuse, which again is more than 90 degrees. So you have one big angle more than 90 degrees. I could not put a little box in here. It would be, slanted. And then we kind of connect it. There are some symbols that we use to show congruency. I don't know how much that word will come up in this class, but congruent just means equal in measure. So the symbols in an angle, or symbols that show angles are equal degrees. And it's like this. It'll be this kind of curved thing like that. And that shows us that these two angles are congruent. If we gave the angles letters, we could say here that angle A is congruent to angle B. I looked through the Alex homework. I don't think you really need to know this this language here about congruency, but you do need to recognize that this tells us that angle A is equal to angle B. We can use that little open mouth to represent an angle. But what you need to know is that that's how it tells you that the angles are congruent, that they're the same. We can also classify triangles by their sides. There are three kinds of triangles classified by sides. There is the equilateral triangle, in which all sides are the same length, or congruent. We can have a scalene triangle, in which no sides are the same length. And then finally, an isosceles. It's probably hard to discern E's from C's here. That's a C after the S. Isosceles, in which two sides have equal lengths or are congruent. And the symbols we use here are like tick marks. Symbols to show side lengths are equal. So if we had a triangle, and I'm just sketching these by hand, but if all sides are the same length, you'll see this little tick marks. Well, so let's say that this one is an isosceles, because we have two congruent sides. I really think you're only asked about the sides here, but in an isosceles triangle, if these two sides are the same, then the angles opposite each side are the same. So the isosceles, you'll see in Alex might look like this, where you have both the tick marks to show that the sides are congruent. That's the tick marks. If we had an equilateral triangle, then all sides would be the same. And again, if your sides are the same, then the angles opposite would be the same as well. So it could look like this. It could have just the tick marks on these sides. If you have any questions about classifying triangles, let me know. But now we will look at the Pythagorean Theorem. It's one that most people remember. A squared plus b squared equals c squared. So in a right triangle, we'll know that it's a right triangle because of our 90-degree angle. The side that's across, so they use this word opposite in math. If the side that is opposite the right angle, we're talking about the side that is like directly across from the right angle. And that side is called the hypotenuse. C is your hypotenuse. The other sides, your A and B, it really doesn't matter which one is A and which one is B. They're just called the legs. And you will see that terminology in Alex. Again, it doesn't matter which one we call A, which one we call B, because it's A squared plus B squared equals, and this is the one that we have to be correct about, C squared, and C is the hypotenuse. So again, the formula, we're talking about squared dimensions. That's a question in Alex somewhere about, are we talking about if it's area of a circle or a triangle? Are we talking in 1 dimensions, 2 dimensions, or 3 dimensions? Area is always in 2 dimensions. So it would be like meters squared. Here, we're solving for the missing side length. So this does not talk about angles. We're talking about side lengths here. And since we solve for c squared, make sure that you take the square root. And again, that's a button on your calculator. The second function of the x squared button, the square root of 25, for example. What number times itself equals 25? The answer is 5. So make sure you take your square root. And sometimes Alex just wants the answer as like the square root of 10. It'll prompt you to just put your radical as the answer. So let's take a look at an example here. So we'll see a triangle with numbers on 2 sides and then a missing side length. If the missing length is C, directly across from the 90-degree angle, then we're just doing a squared plus b squared equals c squared. Again, it doesn't really matter which one you call A and B. You can call the shortest one A, the middle one B. So it's not just, we're not just plugging in 3 here because it's A squared. So 3 squared plus 4 squared equals C squared. Squaring something means we multiply the base times itself. So 3 times 3 is 9. 4 squared is 16. And this still equals C squared. We can't just drop the exponent of 2. To get rid of it, we have to take a square root. So 9 plus 16 is 25. And again, I'm repeating this, but the mistake students make is they'll just put 25 as the answer. We must take the square root. So to get C by itself, I don't want to know what C squared is, just what C is, what this missing side length is. So we take the square root of both sides. The square root of 25 is 5. And if I take the square root of a variable that is squared, those are like canceling functions. Squaring something and taking a square root cancel each other out. And our answer is 5. 3, 4, 5 is one of the most common right triangles. And if you're watching this, then I'll just tell you that a lot of the right triangles that you end up solving for, I know when I'm in class making one up off the top of my head, I always just use a multiple of the 3, 4, 5. Multiply everything by 2. 3 times 2 is 6. 5 times 2 is 10. And so if you see a triangle with a hypotenuse of 6 and a hypotenuse of 10 and a leg of 6, well, the part that's missing is the 4. 4 times 2 would be 8. Multiply everything by 3, and we have a 9, 12, 15 right triangle. So you can kind of just spot those once you get used to them. But a lot of the right triangles you'll be asked to find missing sides of, if they come out to whole numbers, it's often a multiple of the 3, 4, 5. I'll show you one more. Well, I guess 2 more. One is like this. And the problem I saw had dimensions on it. So 16 feet there. Here's our right angle. So our hypotenuse is given to us of 34 feet. And the problem I saw, it labeled the missing leg as A. So again, draw this arrow if it helps. That is our C. If we're across from the right angle, that's our C. So our formula is A squared plus B squared equals C squared. We are not solving for the hypotenuse now, we're solving for a leg. And so we just subtract. There's different ways to do this in the calculator. Most of you would probably clear the exponents first. So 16 squared is 256. 34 squared is 1156. And now we just subtract to get A squared by itself. What I meant by other ways to do this in the calculator, the easiest way is just to do 34 squared minus 16 squared. Or we can clear out the exponents first, either way. we get that a squared, and here 1156 minus 256 is just 900. Again, don't put 900, just look at the dimensions. A leg cannot be longer than a hypotenuse. So if you said 900 is the length of this leg, that where the triangle has a hypotenuse of 34, that would be very wrong. Take the square root of both sides, and the square root of 900 is 30. The last triangle problem I'll do, it just gave you a text prompt. So it tells us that a tennis court is 112 feet long. I do get lazy about not putting the dimensions here. So again, you will have a couple of questions that ask you to put in a dimension. If we're talking about here, we're just looking at a side length. So that is a single dimension. We're not calculating area. So this would just be 30 feet. A tennis court is 112 feet long and 55 feet wide. And it says, what is the length of the diagonal? So the diagonal is just the hypotenuse. This is how they measure like TVs. The dimension that they mention the dimension that they advertise of like a 50-inch TV, that is the diagonal. That is 50. So if we imagine like a court, the diagonal makes the hypotenuse. We have a short side of 55 and a long side of 112. So it would just be 55 squared plus 112 squared equals c squared. So I put that in the calculator and I get a big number. 55 squared plus 112 squared. I can take the square root of that number, and it will tell you to abbreviate, or not abbreviate, to round to a given decimal. So we'll say to one decimal, that's 124.8, getting rounded up. If you have any more questions about that, let me know. We'll look at number 14 at the end. That's a Pythagorean question. But let's talk about circles for a bit. You only have a couple questions about circles. We need to know that the area formula is pi r squared. So that's pi times the radius squared. Now, some of you know that there is a pi button in the calculator, but they actually don't want you to use that on these questions that it asks you. So, let me pull one up. The radius, R stands for radius. That is the half the distance. If I made a line that went from end to end, that would be called the diameter. I don't think you need to know that here. So this line right here is the radius, R for radius. So it will tell you either to use 3.14 for pi, about 3.14, or sometimes it will tell you to use, I think it's 22/7. Yeah, because 22 divided by 7 is about 3.14. So this is where your answer is in squared dimensions. So like feet squared, meters squared, whatever it asks for. So it will give you the radius. Here's one of 3.2. And ask you to find the area using either 3.14 or 22/7. Oh, and it says round to the nearest in this particular problem. Nearest whole unit. So that means whole number. So look at each question as for what decimal it wants you to round to. So we're going to use 3.14 for pi. There we go. So 3.14, that's our pi, times the radius squared. So 3.2 squared. And we get 32.1536. This is not a 5 or above, so we round down to 32. Let's say this is in meters, so 32 meters squared. Those are the only kind of circle questions you have. But students might have a question about number 14 in the homework. We'll kind of abbreviate here. But let's say that there is a 29-foot long wire to be tied from a stake in the ground. So from the ground in a stake to the top of a 21-foot tall flagpole. And the question will be, how far is the rope from the pole? No, it's not a rope, it's a wire. But, you get. So I think it's helpful to kind of draw this out here. We have a little, flagpole that is 21 feet tall. We have this wire in red that's tied from the top of the flagpole to a stake in the ground. And that's the wire, and that's 29 feet long. So it asks us to find basically a leg here. It's not the hypotenuse, so it's a leg. How far from the pole is the rope tied to the stake in the ground, I think is the question. And so these are our legs. That's our hypotenuse. So a squared plus 21 squared equals 29 squared. and it's just a Pythagorean problem. I like to do it that way. 29 squared minus 21 squared is 400. We can take the square root of that. You know, if I type second in the negative symbol, it brings up the previous answer. So that's taking the square root of our previous answer, 400, which is 20. Quick way to check yourself is the leg that you just solved for shorter than the hypotenuse? If it's longer than the hypotenuse, it's definitely wrong. So, hope that helps. Let me know if you have any questions.